Hi, I'm recording this video to assist you on the question as a review for the final that involves this exercise. So basically they tell you that you need to determine the mode of inheritance of different crosses of different breeds of mice, and you have originally three different strains of mice, and then they give you a table that looks like this one right here. So from there you identify that there is complementarity in the strain 1 and 2 and 1 to 3. In other words, these are two different genes. There are different genes from each other. In contrast, the heterozygote from strain 2 and strain 3 follow a 3-to-1 Mendelian ratio inheritance, which makes you believe that this fails complementarity, which means that these are actually the same gene. So what comes next is the introduction of a new strain of mice, and that new strain of mice is gonna be is gonna be in heterozygosity. And what they tell you, they give you this information, this nomenclature for the three strains that you have. And what they tell you is that this new fourth strain is fails to complement with the three different strains. So we know that strain 2 and 3 are in the same gene, which means that the new strain 4 must be heterozygote for both of the genes in order for it to also give a ratio 3-to-1 when with all of the other strains. So they give us this nomenclature right here to designate our different strains, the genotype for different strains. So we have one gene A and one gene B, and then we have two different type of mutations for the gene B for strain 2 and strain 3. So I'm going to change the nomenclature here in order to make it clearer and with something that is more consistent with the way we have been talking about this in the course. So I'm gonna use ST for strain 1, ST1, and they tell us that these genes are tightly linked, which means that there is no recombination between them. So I'm just gonna call this one ST1, it's gonna go with ST2, and this is gonna be both wild types. We know that strain 1 mice are heterozygous, so the other one must be ST1 minus and ST2 plus. The second one is going to look like this. So here we observe that this strain is homozygote for both of its copies of the ST1 gene from the strain 1, and is instead heterozygous for the ST2. Okay, so I am also gonna call this one 3. I'm gonna add a 3 here because this is the same mutation as the one in the strain number 3. Okay, so these are the two different genotypes that we can have. And then we add the third one. So the third one is gonna be it's not gonna be ST4, but instead it's gonna be ST1 plus and ST2 3 plus, and then the opposite. In other words, it's gonna be a mutant that for both of the different genes, one from each of the strain 1 and the other one from 2 and 3. So it's gonna look like this. Okay, and we have two options for the genotype. So if you make your Punnett square by crossing a heterozygote with this genotype, calculate first the gametes that it can produce with the gametes of either of the individuals with the genotype from the strain 1 and strain 2 respectively, you should notice that you're gonna get a ratio of 3-to-1 phenotypes of a normal wild type in this case wild type is alive, and then one of miscarriage in the uterus. Okay, so the thing is that we can have two different types of gametes for our strain number 4. It can look like that, which would be a cis configuration, or we can also have it like this, which would be a trans configuration. Okay, so if you cross two heterozygote mice that have this genotype, you should obtain a ratio of 1:1 phenotypes of normal to miscarriage. So let's test that. So remember that these two genes are tightly linked, which means that in terms of inheritance, they are moving together as one single gene. So the total number of possible gametes that these mice can produce is going to be 2. They're going to be passed like this. This is one gamete, and this would be the other gamete that this mouse can produce. Okay, now this is going to be an F1 times F1 cross. So we are crossing two heterozygous. And what we should see is that and when we observe here, but once I filled up the Punnett square, is that, sorry, one second. So what we observe here is that there were going to be two genotypes out of this Punnett square that produce miscarriages. And there is another two that are going to produce a wild type phenotype. So this one and this one belong to one type of offspring that are going to have two copies are going to be homozygote recessive for the mutation in the 2-3 gene. So this is going to be a miscarriage. And the same happens for the opposite side in the diagonal, but in this case for the one for the first strain gene, right? For the gene that belongs to the first strain. So this is also going to be a miscarriage, and the other two are going to be the wild type alleles, the wild type phenotypes.